Let's turn though to a fascinating story because scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe.
Really massive structure in the universe. So these are the biggest things in our universe. So it's made up of galaxies and galaxy clusters.
Once again, NASA has come out to reveal hidden truths, the secrets that have been held by the universe. Unlike what you are thinking, they are not aliens, but they are also quite important because these revelations have changed the course of what we have always known. We get to witness a universe full of odd objects that may operate under entirely different laws than the rest of the solar system. Countless small planets, extreme trans-Neptunian objects, and strange asteroids reveal a world that was previously virtually unknown. So what exactly has been hiding in the Kuiper belt? This video holds the answers that you are looking for. The Kuiper belt has been known for a long time. In the 1950s, astronomer Gerald Kuiper identified a structure behind Neptune that resembles the asteroid belt between Mars and Jupiter. Kuiper came to this conclusion because, despite their invisibility, the objects orbiting the Sun on Earth leave traces in the overall structure of the solar system. With advancements in technology, we have gained more insight into this mysterious location. About the Kuiper belt. A tiny object known as 1992 QB1 was found in 1992 by Dave Jewett and Jane Lau of the University of Hawaii. It was orbiting the Sun at a distance of roughly 40 astronomical units beyond Neptune. Scientists predict that there are several 100,000 objects larger than 20 miles across waiting to be discovered in that huge region of the solar system. Since then, more than 3,100 comparable objects with orbits beyond Neptune have been detected. We refer to these as the Juniper Belt bodies, in remembrance of Dutch-American astronomer Gerald Kuiper, who postulated the possibility of small things orbiting beyond Neptune in the 1950s. The Kuiper belt has a width of 25 to 50 AU, or 3.7 to 7.4 billion kilometers. The inaccuracy in the data is due to the region's limited exploration and the presence of elliptical and obliquely orbiting objects in the scattered disk. Researchers estimate that there are over 100,000 objects in the Kuiper belt, with a diameter of more than 100 kilometers, with a total number of billions of objects, including smaller pieces of ice and rock. The Kuiper belt contains remnants of the early phase of the solar system, including dwarf planets, comets, rocks, and dust. These objects share a common feature. They lack sufficient mass to become large, round objects. Even the smaller planets in the belt were unable to accumulate enough mass to become fully formed planets. Finding objects in the Kuiper belt. Finding objects in the Kuiper belt did not come easy. Even with the greatest telescopes in the world, KBOs appear to be dim stars due to their small size and remote location. The first classical Kuiper belt object was only found in 1992 because they are so elusive. Because Kuiper belt objects, KBOs, travel slowly around the stars, astronomers can locate them among the multitude of stars. We get to see precise photographs of the sky that were taken many hours or days apart, showing weak points of light that have slightly changed position in comparison to the distant stars that appear stationary, due to the shifting orbital locations of Earth and the Kuiper belt objects. Thus, you can say that the Kuiper belt objects are those whose locations vary slowly, indicating their great distance from the Sun. NASA's New Horizons discovery. Since the discovery of the first KBO, 1992 QB1, more than 2,000 Kuiper belt objects have been detected. However, the size and distance of these objects made detection difficult, adding to the time-consuming finding process. In recent years, some scholars have decided to refer to this region as the trans-Neptunian region to better reflect its greater nature. Despite its vastness, only 2 spacecraft have explored the Kuiper belt to date. NASA's New Horizons is the only space mission that has explored Kuiper belt objects up close. In 1983, NASA's Pioneer 10 spacecraft made history by becoming the first to pass into the Kuiper belt. However, it did not come across any Kuiper belt objects on its voyage. The New Horizon was launched in 2006 and orbited Pluto in 2015. Then, in 2019, New Horizons investigated another KBO called Arrokoth, making it the furthest object in the solar system visited by a spacecraft. The mission's team is currently looking for a suitable object for New Horizons to undertake another flyby. So what are the new objects that were discovered? Well, that is why this video exists. Pluto. Pluto was formerly known as the 9th planet in our solar system, but right now it has been reclassified as a dwarf planet. This was quite a big decision for NASA, as it now allows for access to the enigmatic Kuiper belt beyond Neptune. Its discovery in 1930 created quite a sensation, leading many people to conclude that our search for planets has finally come to an end. What we didn't realize at the time was that Pluto was not alone in its orbit. In fact, for many decades, our knowledge of Pluto was just information gotten and knowledge in itself. This indeed is where we bring in the philosophical world of appearance versus reality. Dwarf objects. The discovery of additional little planets bouncing on the outskirts of our solar system was nothing short of amazing. Since the discovery of objects such as Eris, Makemake, and Haumea, our fascination with these enigmatic celestial entities has risen. It's possible that these dwarf planets, which now include Pluto, form a separate realm, a world on the outskirts of our cosmic neighborhood that we're only beginning to understand. Cold classical KBOs. The term cold refers to the round, uninclined orbits of these objects, not their temperature. Cold classical KBOs are located in a limited zone, around 6 AU wide, 42 to 48 AU from the Sun, and 3 AU thick. There are no huge KBOs in this category, and they are redder than other KBOs, suggesting a separate origin. These objects are referred to as classical KBOs, since they orbit in the manner that KUIPER described. Arrokoth, the New Horizons Kuiper belt flyby target, falls under the cold classical category. The cold classicals appear to represent the Kuiper belt's gravitationally unperturbed and fundamental material. Hot classical KBOs. The term hot refers to the non-circular and inclined orbits of these objects. Despite having a comparable average distance from the Sun as cold classical KBOs, their eccentric and inclined orbits cause them to deviate significantly from that average position. Like most KBOs, their sizes and colors vary, and they contain larger and grayer items than cold classicals. The hot classicals are in a disk about 12 AU thick. Resonant KBOs. These are locked in an orbital dance with Neptune, which means they orbit in resonance with the planet. Pluto and other 3-2 resonant objects orbit the Sun twice for every 3 orbits made by Neptune. These are also known as Plutinos or Little Plutos. The 2-1 objects are further away from the Sun and orbit once for every 2 orbits of Neptune. The Kuiper belt contains dozens of resonance groups. Scattered KBOs. This has most likely drifted too near to Neptune in the past, and Neptune's gravity has thrown them into unstable orbits, sometimes sending them hundreds of AU from the Sun at their farthest point and bringing them closer to the Sun than Neptune at its closest. Extreme trans-Neptunian objects, ETNOs. The discovery of extreme trans-Neptunian objects, ETNOs, mark the beginning of a new era of exploration in the farthest regions of our solar system. These uncommon celestial bodies, distinguished by their unique orbits, have attracted the interest of astronomers worldwide. Among the most notable members of this newly discovered class of entities are Sedna and 2012 VP-113, sometimes known as Biden. These objects lie far beyond Neptune's orbit and, unsurprisingly, have challenged our understanding of what we know. Sedna especially revolves at an amazing distance of up to 936 astronomical units, AU, from the Sun, an orbit that takes more than 11,000 years. This discovery in 2003 challenged traditional notions about the extent of the solar system and implied the presence of a hidden population of distant objects. Similarly, Biden's orbit is greatly stretched and eccentric, reaching distances of up to 80 AU from the Sun. This anomalous reality implies the gravitational effect of an undiscovered distant object, sparking speculation about the existence of a 9th planet. Indeed, the orbits of ETNOs, like Sedna and Biden, have sparked scientific interest in the possibility of an enigmatic and elusive Planet 9. The KBO's features. With a diameter of 2,377 kilometers, Pluto is marginally larger than Eris, making them the 2 largest objects in the Kuiper belt. 3 to 7 more KBOs, including Charon, Pluto's biggest moon, are known to exist. Their diameters range from 950 to 1,500 kilometers. The colors and reflectivities of objects in the Kuiper belt vary. With an average reflectance of 0.5, Pluto is incredibly brilliant. In contrast, only roughly 10% of the Earth's moon is reflective. Atmospheres of Moon. Approximately 125 KBOs have partners, with more being discovered all the time. They are often referred to as binary KBOs, since the objects are similar in size, making it difficult to distinguish between the KBO and the Moon. The most well-known pair is Pluto and Charon. Charon orbits Pluto every 6 days at a distance of around 17,000 kilometers. Some pairings have far slower orbits, up to 17 years, and larger separations, whilst others are extremely close. We don't know how these binary KBOs develop, but they are most likely the result of collisions or near contact with other objects. The Kuiper Belt contains crucial information on the development of our solar system. Scientists study Kuiper Belt objects KBOs to learn about the beginning of planets and planetesimals. Recent missions such as New Horizons have thrown light on ancient KBOs, such as Arrokoth, providing insight into planetary formation in space. With almost 2,000 catalogued KBOs and the possibility of hundreds of thousands more, the Kuiper Belt remains an ideal setting for investigation. We can learn about the solar system's history and evolution by studying its orbits and compositions. Discoveries in the Kuiper Belt have previously revealed details such as Neptune's migration, demonstrating the continual evolution of our understanding of the universe. Till next time, do not forget to hit the subscribe and like button. Also, feel free to share your thoughts in the comments section.